Hello and welcome again as we consider yet another multiple choice question for IB chemistry. This one says, Z moles of copper is deposited from copper sulfate aqueous by a current I in a time t. What is the amount of silver in moles deposited by electrolysis from silver nitrate by a current I divided by 2 in time 2t. This particular question is associated with the application in topic 19 of determination of the relative amounts of a substance deposited in electrolysis by a given amount of electricity. And it's kind of obscure because you tend to focus a lot on other areas of topic 19 and this one becomes neglected. What you need to know is this: 1 Faraday deposits 1 mole of electrons. 1 Faraday equals 96,500 coulombs. And then you need to know this equation: Q, the quantity of electricity, equals I, the current in amperes, multiplied by T, the time in seconds. Q equals IT. And that 1 Faraday deposits 1 mole. If we're getting Z moles of copper deposited, then Cu2 plus has to get 2 electrons to form Cu. To get Z on this side, let's say that Z is 1 mole of copper, then you need 2 moles of electrons. So the quantity of electricity needs to be 2F, so that 1 mole of copper ions can get 2 moles of electrons to form 1 mole of solid copper, which is designated as Z. Z is the amount in moles of copper deposited. Q would then have to be associated with 2 moles of electrons so that it can give Z, the amount of copper deposited. With that reasoning, then we can look at the time and the current associated with the silver. And I divided by 2 multiplied by 2t, that would also be equal to I multiplied by t when this 2 cancels with this 2. So in both cases you have the same quantity of electricity Q. That's what you want to realize. But in the case of copper, Q is associated with 2 moles. So you have basically 2 Faradays, if you want to look at it like that, allowing for the movement of 2 moles of electrons and the formation of Z moles of copper, which we can call 1 mole of copper. Now if you take that same quantity of electricity, which is equal to 2 Faradays, and you apply it to silver, then silver only needs 1 mole of electrons. So what you'll be having is, you'll have enough Faradays or enough of quantity of electricity so that 2 moles of electrons could be moved. And if 2 moles of electrons are going to be moved, then you'll need 2 moles of silver ions and you'll get 2 moles of solid silver being formed. So therefore the amount in relation to this question would be 2Z. And the answer to the question therefore is D.